Third law. So every action, there is an equal and opposite reaction. So action-reaction pair acts on different bodies. What I'm writing. Acts on different bodies. Okay, now tell me, will they be equal, like balanced force, not equal? Let's take it as balanced force.
Sir, like after the, I didn't get the question, sir. Can you repeat it?
I'm saying action-reaction pair, are they balanced force?
Sir, yes.
Think it again.
Not balanced, sir.
Unbalanced.
Why?
Because they're acting
Because
on two different objects.
Exactly. They are acting on different object. That's why it is not balanced. Because when we were discussing about balanced force, it was acting on same object. If you observe seesaw, when it is balanced, now it has changed momentum. So that object is not in balanced position now. So they are not balanced force. Or they are not in balance because they are acting on different bodies. Okay. So we saw here force equals to change in momentum by time. Even we wrote, right? It's not scrolling, man. Yeah. Even we wrote this formula. Where is M1, M2? Where is it? Where we wrote? Here M1, M2, P1 equals to M1, V1, P2 equals to M2, V2. Okay. Let's discuss about that. So one object and another mass. Object 1, object 2. It has mass M1, another object has mass M2. This is before collision. Before collision means before colliding. We are saying it has initial velocity u1, it has initial velocity u2. Now it collide M1, M2, it collide. Then M1 has some velocity, name it as v1. M2 gain some velocity, let's name it as v2. So initial velocity of M1 is u1, final velocity of M1 is
U2.
v1, final. Now initial velocity of object 2, M2 is v2, sorry, u2, and final velocity of object, that is v2. Why we are saying final? Because after this is after collision. Here it collide. We can say during collision. Before collision, initial. See, if you can't remember, we can remember this way. Initial all are U. Final all are V. So M1 has U1. M2 has U2 for initial or before. After collision, M1 gain or M1 lose, whatever it is. That is V1. M2, V2. Let's find out initial momentum equals to final momentum. Equals to final. This is law of conservation of momentum. Okay. Okay, so someone tell me what would be the initial momentum?
M into V.
M into V. Okay. Anyone else?
M1 into V1.
V1. Okay. Anyone else? Yes, Krishna Pranav. What do you think? What would be the initial momentum? From this one. See, I'm not asking what we wrote before. I'm asking from this. From this one. I'm asking from here.
Yes, sir. Zero.
What is initial?
Zero, sir.
U?
U is only zero, sir.
Okay. Fine. Yes,
U is
Dipshika.
equal to V.
So see again, say that again.
U is equal to V.
U equals to V. Okay. Yes, Dipshika.
I don't know, sir.
No idea? Okay, no problem. Yes, Pulatsya. Am I back?
Sir.
Okay. Yeah, again fluctuated. So I don't know. Pulatsya.
Sir, but you're audible.
Yeah, now it's audible because the few seconds it went. So I don't know Pulatsya answer or didn't. Did he answer?
No, sir.
No, sir.
Okay, no problem. So initial, we will take all the initial values, all the initial momentum, we will add it. Final momentum will add it. So see, what is the meaning of this law of conservation? I'll just give you a small explanation, then we can end. Don't worry. So initially we have some velocity here. Let's assume this object was at 0. It has some velocity. So now total velocity, like let's assume here this object was at rest. Assume. Rest means u is 0. Now, after striking this first ball, this is first, second. So after striking this first ball, it came to rest. So this became at rest. That means V1 equals to 0. So 0 plus M1, M2, V2, M1, U1. So what do you observe here? What is the observation? What do you observe? Give me your statement. Yes, I want
But
statement.
M1
The
Yes.
momentum before collision is the momentum after.
Exactly. Yes, Bhumika, you're saying something?
the same thing.
Acha. Anything else you want to add, Krishna Pranav? Or Satvik? Deepshika? Okay. Then let's conclude. Yes. So what happens here? Totally what velocity he was having in terms of momentum, everything is transferred to that second object. The total momentum is transferred to the second ball from the first. Or this ball, let's take it, that striker. Striker, his momentum, his total momentum is transferred to that coin. So that striker came to rest after hitting the coin. That's what it means. Clear?
Yes, sir.
Any doubt in this class?
No, sir.
No, sir.
No,
Okay.
sir.
Shall I stop sharing?
Okay, sir.
Okay, sir.
Okay, sir.
Okay then. Bye-bye everyone. We'll see next class.
Bye, sir.
Thank
Bye-bye.
you. Bye,
Bye,
sir.
sir. Stay safe. Bye, sir.
Bye-bye.